Hello and welcome everyone, we're happy that we're all together again. In this tutorial we will take an overview on the electrical faults. So fasten your belt and let's get started. The aim of this tutorial is to learn about the basic idea behind the electrical faults to know why it's danger and why we need to avoid those faults. So let's go ahead. First of all, if we need to know what is the basic idea behind the electrical fault from the electrical point of view to understand why it's called a fault and why it's a danger one, we can discuss an example. Suppose we have that power source that produces 220 volts and it's responsible to feed that load that has a total resistance of 100 ohm. And we connect that power source with that load through those wires. So if we need to calculate the electrical current that will pass through that simple circuit, we easily divide the voltage of the source over the resistance of the load. So it will be 220 over 100, which gives a current of 2.2 amperes. But this 2.2 ampere is called the rated current, and it's the current that the load absorbs at the normal case or the rated case of operation for the electrical load. And for that, all the circuit components are designed to withstand the rated current. For example, those electrical wires have a cross-sectional area that withstand that rated current. So that's about the nominal case or the normal case of working. But suppose now we turn it to the fault case at which we have the line wire is touching the neutral wire by mistake. So this case is called a fault because the line wire mustn't touch the neutral wire anyway. So at the normal case, the line wire mustn't touch the neutral wire. But by a mistake, this may occur which produce that fault. And at that case, what will happen is that the electrical current will find that it has two branches to move through them. The first branch is to move through that wire, and the second branch is to move through that electrical load. But from the electrical basics, we find that approximately the total current will move through that wire and approximately no current will pass through that electrical load. And this is because the resistance of that wire is very smaller than the resistance of the electrical load. So the wire resistance is about 0.2 ohms while the load resistance is 100 ohm. And because the electrical current is inversely proportional to the resistance, we find that the larger current will pass through the smaller resistance, which is this wire here, while the very smaller current will move through that larger resistance or that load resistance. Or in other words, we say that the current prefers to move through the easier path that has the smaller resistance. And for that reason, this failure condition is called the short circuit condition because the circuit has become a short one because there is no current that reaches the load. So the circuit is cut now or it's shorted on the wire or that wire that has the line is touching the neutral. But the current calculated now is not the nominal current or it's not the rated current, but it's the full current as the circuit is not at the rated condition but it's at the full condition. So the full current now will equal the source voltage over the wire resistance, but as we said the wire has a resistance of 0.2 ohms, so the full current equals 220 over 0.2 which equals 1100 amperes. And for the first glance, it appears that this current is a very huge one when compared to the rated current, as the current has increased from 2.2 till 1100 amperes. So the full current is about 550 times larger than the rated current. And the problem now is that this circuit is designed to withstand the rated current, not the full current. For example, the electrical source is designed to supply the rated current, not a larger current like that full current, and also the electrical wires and cables are designed with a cross-sectional area to withstand the rated current, not the full current. So in that case, the cables can withstand 1100 amperes anyway, which means that the wires will burn out. And the power system also will not cope with that faulty case and it will be in a failure. And from here we come up with the idea of the electrical protection that is aimed to protect the electrical circuit from any fault that may occur by mistake like that case here. More than great. So that's about this tutorial at which we have discussed the basic idea about the faults. Hope that's clear right now. Thank you for watching and see you in next tutorials.